This is lesson 2.1 for secondary 2 math. This is about dilations. So starting out, we're going to be looking at similarity, and we're going to be looking at these two triangles here. So we can see that we have the two triangles. They have the ordered pairs. So starting out, let's talk about the vocabulary. So what is a dilation? A dilation is a transformation. It produces an image that is the same shape as the original figure, but it is a different size. So that's not like congruence. Congruence is same size, same shape, but similar is the same shape, but just a different size. The dilation uses a center and a scale factor to create a proportional figure. A center of dilation, that's where the shape is dilating from. And so if we look at this picture over here on the left, the 0, 0 is marked as my center of dilation. So the length from there to there is going to be proportional to that length. Same with that versus that, and that, versus that. So those are all similar in length, or proportional in length. And so the center of dilation is important because if you were doing a different center, then this shape would end up somewhere else. Okay, the pre-image, remember we've learned this before, that the pre-image is the original figure before the transformation. So in this picture, the purple figure will be the pre-image. And I can tell that because of the notation. Notice that that says B prime, and that's the notation for an image. So the image is after the transformation has taken place. Okay, next thing is the scale factor. And the scale factor is the ratio of the image to the pre-image. So we're going to start with what we end up with to what we started with. So for this one, if I look, this one is starting at 3 and going to 12, so this is a length of 9, whereas this one is a length of 3. So this is going to be a ratio of 9 to 3, or 3. So my scale factor is 3. So this is a different example. If my original figure has a length of 2 and the new figure has a length of 4, then the scale factor is 4 to 2, or 2. Different types of dilations, you can have a reduction, you can have congruency, and so we don't really consider that when we talk about dilations, or you can have an enlargement. So the enlargement or the reduction are the two that we're going to be talking about. Okay, so in this next set of problems, we're going to still take the picture that we had, and we're going to answer these questions. So number 1, it says calculate the lengths of the following segments. In case you forget, here's the distance formula. So from A prime to B prime, we actually don't need the distance formula to do that because we can see that it starts at 3 and ends at 12, so that's going to be 9. And then AB we already figured was 3. Okay, and then AC and A prime, C prime, that's this one, and that's easy enough to tell. The AC is going to go from 2 to 6, so that's a length of 4, and A prime, C prime is going to go from 6 to 18, and so that's a length of 12. And if you'll notice, 12 to 4 is the same ratio as 9 to 3. Okay, BC, we are going to need the distance formula for that. So to do B prime, C prime, we're going to do the x coordinate minus the x coordinate squared, and then the y coordinate minus the y coordinate squared. So we're going to have 9 squared plus negative 12 squared, so it's going to be 81 plus 144. And so that's going to come out to be the square root of 225, which we know is equal to 15. So B prime, C prime is 15. And then don't just assume, we're checking here, so we need to make sure that that length is really what we think it is, and we're not just going to assume that it's 5. So we're going to do the distance formula with that. So I'm going to say 4 minus 1 quantity squared plus 2 minus 6 quantity squared. We can see that's going to be 3 squared plus negative 4 squared, so that's 3 squared, which is 9, plus 4 squared, 16. We recognize that as a 3, 4, 5 triangle, and so we can see that that is in fact 5. So the ratios are all consistent. So do you notice anything interesting about your answer? So all have a ratio of 3 to 1, or a scale factor of 3. So when we talk about the ratio, it's a proportion. When we talk about the scale factor, even though it's a ratio, if it's 3 over 1, we're just going to say 3. So what do you notice about the angles in each of the triangles? So let's look at the angles. So it's obvious to see like the right angle, they're the same, okay? And then, but you notice like these other angles, this is not going to be a third of this angle. They're going to be exactly the same angles. They have to add up to be 180. So these two angles in the purple, they have to add to be 90 degrees. And these two also have to be 90 degrees. So it can't be 3 times bigger in the big triangle. So the angles are the same. So write that angles are the same. Okay, the next one, number 4, it says find the slope of BC and B prime C prime. So let's take a look. That's the hypotenuse of these triangles. And so I'm going to find the slope. And so remember to find the slope. I'm going to erase some of this. To find the slope, we are going to do change in y over change in x. So for B prime, C prime, we're going to say the slope. It's going to be 18 minus 6 over 3 minus 12, so that's 12 over negative 9, which reduces to negative 4/3. Okay, let's find the slope of BC, and so that's down here. We're going to say 6 minus 2 over 1 minus 4, so make sure you're doing the y's on top, and so you can see that the slopes are the same, and so that tells me the angles are the same too. So the slopes are negative 4/3 on both of them. So do you notice anything interesting? Okay, the slopes are the same, and that tells us that the angles are going to be the same too. Number 6, it says using a ruler or a straight edge, draw 3 line segments. So we're going to connect O, which is the origin or the center of dilation here, to A prime and to B prime and to C prime. So let's do that. So I don't have a straight edge that I can use with the program I'm using, but I'm going to draw a line like that, and then so what do you notice about that? Look at the picture. Do you notice that if we start at the center of origin and go to the B prime, the image, it passes through the pre-image every single time? Okay, that's not a coincidence, and it doesn't happen just sometimes. It's going to happen all the time. So when we see something like that, I'll just put check because we did that. So anything interesting, so it's going to pass through the pre-image. That's one way you can tell if you actually have a dilation, because that's always going to work. Okay, so then the next question, it says, if the scale factor is less than 1, how would the pre-image and the image compare? So think about what that means. It means if we had a scale factor of, say, 1 to 2, now remember that this is the image and this is the pre-image. And so that means that your image is only 1, whereas the pre-image was 2. So that means that we're getting smaller. So if your scale factor is less than 1, it's going to be a reduction. And so if you look at the scale factor, you can tell just by looking at the scale factor if you're looking at an enlargement or a reduction. What can you conclude using the scale factor about an image and a pre-image? So what we can say is we can say if the scale factor is, and there's a tipping point. So what would it be if it was a congruence? So if we're going to go like to a shape and a congruent shape, what would the scale factor of that be? If this was 5 and this was 5, that would be 1 to 1, or 1. So if the scale factor is equal to 1, then that's congruence. If it's smaller than 1, so if it's 1/2, that's going to be a reduction. And if it's greater than 1, it's going to be an enlargement. And so that's what we can tell just by looking at the scale factor. Okay, in the next examples, it says we're going to be working with the dilations in the center of origin, or the center of dilation. And so it says the following transformations represent dilations. Determine the scale factor and whether the dilation is an enlargement, a reduction, or a congruency transformation. So if we look at this picture, we can tell this is the pre-image and this is the image, and I can tell that this is bigger than this one. So it's obviously an enlargement. So if I'm just looking at that, I mean, I can tell. That also means, though, when I figure out the scale factor, it has to be bigger than 1. So I can compare the sides. So I could say 12 to 4, or I could say 9 to 3, or I could say 15 to 5. No matter which way I do that, the scale factor, which, by the way, the abbreviation for scale factor is K, it's equal to 3. And since K is greater than 1, that verifies that I have an enlargement. Okay, the next one, number 2, it says draw the dilation image of each figure with the center of dilation at 0, 0 and the given, I'm not sure what that is, the given scale factor. So when the center is at 0, 0, that's the easiest one to do. It's very intuitive. If the scale factor is 4, that means that I'm going to have a bigger square in my image. And so if you're starting at the center of dilation, everything's just based on the relationship to the center. So to get this vertex, I'm going to go over 1 and up 1. So I'm just going to go over 4 and up 4 to get my A prime. We'll call that A, so A prime. And so to get, we'll call that B prime, or B. And so we're going to go back 4, up 4 to get B prime. And same thing with the other points. So this is, when it's centered at 0, 0, it's really very intuitive, pretty straightforward to do a dilation or a reduction. And so that's how that's going to look. We're supposed to determine the scale factor, so we're going to say, I'm just going to abbreviate that with K. K is equal to 4. Okay, I guess the next one, the center is at 0, 0, scale factor is 1/2, so I'm going to get smaller. Okay, this is a reduction. And so getting smaller. So why don't you pause the video and see if you do this right. It's a little bit different than just a nice, pretty square, but see if you get the reduction right. So pause the video and then come back. Okay, what you can do is, to get to this point right there, you would go over 1 and up 1. So I can just do half of that. So I can just go over a half, up a half, and that would give me that point. To get to this one, I'd go back 2, up 2. So I'm just going to do half of that. So over 1, up 1. Same with the negative 1/2, negative 1/2. And then same with this one being at 1, negative 1. And then I just connect that. And so that's going to be my image, the red one. And that scale factor is equal to 1/2. So if the center of dilation is at 0, 0, that's pretty straightforward. Okay, we're going to do some others that have a different center of dilation. And so on this one on the left, it says the center is at 1, 1. So that means that we're going to start from this point. So if you think about, like, the points are kind of pulsating out from that point. So we're going to go further out instead of going that direction. We're going to go twice as far. And so it's just from the center of dilation, that's where it's kind of like the center of an earthquake or something, epicenter. And so we're going to go, instead of going over 2, we're going to have a scale factor of 2, so we're going to go twice that. So we're going to go over a distance of 4. And same thing going up, we're going to go up a distance of 4. And then if we just connect our dots, we're going to have our image like that. So let's go down to the center being at 2, 0. And so the scale factor is again at 2. And so 2, 0 is this point. So it's really important that you locate your center of dilation first. And then look at what you need to do. So instead of going back 1, up 1, I'm going to do that twice. So 2 and 2. So this is going to be my point right there. Okay, and then the next one, instead of going up 3, I'm going to go up 6. Instead of going over 3, up 1, I'm going to go over 6, up 2. This point is going over 0, up 0, and 2 times that is still over 0, up 0. So what I'm going to do is I'm going to connect these points. Remember what we learned earlier about if you draw a line segment from the center of dilation to the image, it's always going to pass through the corresponding point of the pre-image. So notice how that does that. Okay, that's not coincidence. So that will help you make sure that you have the correct figure. Okay, then moving to the right, these are from 0, 0, scale factor of 1/2. So what's going to happen is this is going to kind of shrink. It's pulling from this point though. And so again, you can do the same thing. Instead of going over 2 and up 2, we're going to do half of that. So we're going to go over 1 and up 1. And so this point will match that point. Okay, and then we do the same thing. So instead of going to get to that one, you're going to go over 8, up 4. So we're going to do half of that. So over 4, up 2. Okay, and then to get to this point, we're going to go over 4, up 6. So let's do half that. Over 2, up 3. And then last, we're going to do this one. So instead, we already did that one. Oh, it's just a triangle. Okay, so we're just going to connect these points. And that's the new figure, the image, and it's the center of dilation at 0, 0, scale factor 1/2. Now, if we would have done the center of dilation at a different point, it's going to look different. Let's just do an example. So let's just say that I'm going to do a center of dilation, say at 2, 2. So let's just say we're going to do 2, 2 instead. How would that change what we have? What it would do is we would start there, and so my pre-image and image would be right there of that point. And then I go from here, I'm going to go 1, 2, 3, 4, 5, 6, up 2, so I'm going to do half of that. So I'm going to go over 3 and up 1. And then instead, to get it to there, I'd have to go over 2, up 1, 2, 3, 4. I'm going to go over 1, up 2. And so that would be my image. And so the center of dilation is important because it locates where your image is going to be. So just be aware of that. You can't just, always do it from 0, 0. It's going to matter. Okay, this one's from 0, 0, scale factor of 1/2. Pause the video, see if you can get it right. Okay, this is what I have for my pre-image. Now, my pencil's a little fat here, and so it's a little bit hard to tell. I was kind of wondering about that line right there, because if I draw this, it looks like I kind of have to mess with it to make it go through. It shouldn't. I mean, if you go from the center of origin, it's going to go like that. So we're going from this. The center is 0, 0. So that's what I'm going through right there, and then that like that. So it looks reasonable. If I had a straight edge, it would be easier to do this. Another way I can check it though is I know that in my pre-image from here to here had a slope of 1, 2, 3, 4 over 2. So that's a slope of 2. And if I look at this line and compare that, that's also got a slope of 2. So that all makes sense. So this is my my image, and it's got a scale factor of 1/2 with a center at 0, 0. Okay, that's it for the lesson. So now you can be ready to do the assignment. Make sure you read the directions and answer all the questions, whether they're asking about scale factor or if it's reduction, enlargement, whatever. Make sure you watch for the center of dilation and pay attention to that and use a straight edge. And thanks for being here.